Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurul Ashikin binti Adenan from DTP 5B.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Husnina binti Muhammad Sofri. I'm from DTP 5B.
And today I'm going to explain about 2 common defects in sandwich structure. First of all, I'm going to explain about what is sandwich structure. Sandwich structure is consists of 2 strong outer layer skin such as fiberglass and carbon fiber bonded to a lightweight inner core material such as honeycomb and plywood. Okay. This combination provides a high strength to weight ratio, stiffness and good isolation properties. Sandwich structure are widely used in industry like aerospace to make plane, automotive to make body part, marine to make boat and construction. However, due to manufacturing errors, operational stress or environmental factor, this structure can develop various type of damage. In this presentation, me and my teammate, we're gonna explain 4 common defects in sandwich structure such as delamination and common crush. Okay, what is fiber delamination? Fiber delamination is the loss of bonding. It happens between the plies layers in a laminate composite. But now we are going to explain about the fiber delamination in sandwich structure. The fiber delamination in sandwich structure is often in 2 situations, is between the fiber layers and the fiber layers, and the second situation is between the fiber layers and the core layers. But it will not happen within the fiber themselves. The fiber delamination is a type of damage that occur in composite materials like carbon fiber or fiberglass laminate, where the layers laminate separate or peel apart from each other. My simple explanation is, okay, think of a composite like a layer cake. Each layers is bonded together with glue. What glue? Our glue is our resin. Okay, delamination is when those layers start to separate like the cake layers peeling apart. The causes of the fiber delamination is impact. Okay, as example, we drop the part of the composite material itself or our laminate part or our tool on the laminate surface. Okay, the second causes is the manufacturing defect such as air bubble, poor resin bonding and contamination. Okay, the third factor is the moisture or thermal cycling, such example repeated heating and cooling or the humidity when we doing the laminate. Okay. The improper curing is also the factor because the resin is not hardened correctly to glue and bond the fiber together. The last factor is the stress concentration because when we put too much force in one small area, it can cause the fiber delamination. The laminate part cannot absorb the too much force, the too much stress on the laminate part itself. Okay. Why is it matter? Is it matter because the delamination can reduce the structural integrity and the load carrying capacity of the material. Okay, how to know there is the fiber delamination there? Okay, first step is we can do the ultrasonic testing to detect the delamination. Our second step is we can do the tap testing to detect the smaller or accessible area to know there happen fiber delamination there. Okay, next I'm going to explain about the matrix cracking. What is it? What is matrix cracking? Matrix cracking is refers to a small crack that form in the resin matrix part of the composite material. It usually happen between the fibers. How did it happen? It happened due to the thermal cycling, repeated loading, impact, or shrinkage during the curing. Why is it matter? It is matter because also the matrix cracking is not immediately cause failure that allow the moisture to enter and slowly weaken the structure over time and may lead to the fiber delamination. How can we detect the matrix cracking? We can detect the matrix cracking during by the visual inspection, dye penetration testing, and we can do the ultrasonic scanning so we can help to detect the matrix crack. Okay, that's all from me. My name is Siti Nurul Ashikin. Thank you.
So I'm going to present about fiber breakage. Fiber breakage ni refers to the rupture of reinforcing fibers in composite materials due to excessive tensile, which is pulling stress. When the tensile load becomes too high, the fiber breaks, weakening the structure. So for the how it occurs is high mechanical loading. It is because overloading the material beyond its design limit. The second one is manufacturing defects, which is errors during the layup process or cutting that cause weak spots. And the third is improper handling or tool damage. It because of careless handling or using tools that damage the fibers. For the inspection methods, first is microscopy. Microscopy is for close-up examination of fiber surface and failures. Next is radiographic testing, which is X-ray, for internal fiber breakage without cutting into the part. And the last common damage in sandwich structure is voids and porosity. Voids and porosity are air pockets or unfilled space inside the laminate. These are defects that reduce the strain and integrity of the composite. For the how it occurs is incomplete resin impregnation. So, it is because of resin doesn't fully wet out the fibers, so it leaving the gaps. Next is trap air. Trap air is happen during vacuum bagging or hand layup if not done carefully. The inspection method for voids and porosity are ultrasonic testing. Ultrasonic testing is detects change in sound wave caused by internal air pockets. The second is X-ray inspection. So, X-ray inspection reveals voids and porosity inside the material structure. So, for the conclusion, delamination weakens the bond between layers, affecting load transfer and structural integrity. Matrix cracking allows moistures ingress and reduce durability. Fiber breakage lowers strain and stiffness by damaging the main load bearing elements. Voids and porosity act as stress concentrators and reduce overall performance. These defects are mainly caused by manufacturing flaws, impact or poor handling. Non-destructive inspection such as ultrasonic thermography is crucial for early detection and safety. That's all from us. Thank you.